another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find a link there to all the back episodes, all over 100 of them, as well as you can find links to all of our Twitter channels and all of our blogs and stuff like that. Once again, I have Jeff Squyres, one of the authors of OpenMPI from Cisco Systems. Jeff, thanks again for your time.
Hey, Brock. Yeah, we're kind of continuing our little trend here of not HPC-specific topics, but things that are either related to or maybe 45 degrees off from HPC or something like this. So today we're going to be kind of talking about analytics and big data and things that actually even come out of that, which is all kind of tied together with the same kinds of things that we do.
Right. The title of the RCE is Research Computing and Engineering, and this is still very solidly into research computing space. So I'll go ahead and introduce our guest. Our guest today is Marcel Kornacker from Cloudera. Marcel, why don't you take a moment to introduce yourself?
Yes. Hi, Brock. Thanks for having me on the show. I'm the founder and architect of Impala. And I joined Cloudera in 2010 and started working on Impala in 2011.
Okay, so Impala is what we're here to talk about. Can you give us a quick overview of what is Impala?
Sure. Impala is in essence, it is an MPP database system, or rather query engine, for the Hadoop ecosystem. So it was specifically designed for living inside the Hadoop ecosystem, and thereby utilizes components of that ecosystem that you would normally find built into what are standard monolithic analytic database systems.
So let me ask the obvious question, which occurred to me and probably Brock and most of our HPC listeners out there. What's MPP?
Yes, happy to explain that. That is database industry jargon for massively parallel processing. So in essence, what that really refers to is a parallel database system that uses what is commonly considered a shared nothing architecture. And shared nothing really means that you have what is called data partition parallelism. So you take an individual query and you break it up into pieces and run the pieces on the nodes that contain the data that is relevant for that query.
I see. So, us with the HPC backgrounds, we have a particular definition of parallel computing. Yours is a little different, but very similar. It sounds like you're running code on multiple processors simultaneously, just kind of not in the same way that we're used to with traditional MPI and HPC kinds of applications. Is that right? Is that a fair characterization?
That is a fair characterization. Typically, in the database world, what you might consider a job, a query, is expressed through SQL, and SQL standard query language is structured query language is basically a form of relational algebra where you declaratively specify what you want from the query. So it is not a program that is executed one statement at a time, but it's really a declaration of what you want out, logically, so to speak. And that gives you a great degree of freedom in terms of figuring out where you need to run what, and also in terms of breaking up the computation into independent pieces. So typically, when you're running a query in parallel, there are lots of large segments that do not need to interact with each other at all.
Okay, so is Impala more of, is it a database replacement? Is it a data warehouse replacement? Or like what market is it kind of looking to, what problem is it trying to solve?
Mm-hmm. Good question. I think we should differentiate a little bit and talk about the terms database, and then also differentiate what you have in the Hadoop ecosystem versus in a more traditional analytic database system. So a database system is really multiple components. It consists of a query engine. It also consists of a storage manager, and it also consists of a metadata repository. And these are all baked into one system and given to you as an analytic database system. In the Hadoop ecosystem, those are individual components. And Impala is one part of the set of components that give you database functionality. So Impala is really a query engine, and you would use it on top of a storage manager such as HDFS, and you also use it in conjunction with a metadata repository such as Hive Metastore. So those three components together basically give you database functionality in the Hadoop ecosystem.
Okay, so I've had some experience with Hive, and I've had experience with a few of those other tools, but they don't really feel that interactive. They feel more like an application you start up and you run some queries against, and they interact with HDFS and everything. What's different about Impala versus those specifically?
So when answering that question, you kind of need to look at the different origins of Hive and Impala. So when Hadoop started out, it was really more geared towards batch-oriented system, or entirely geared towards batch-oriented system. You had MapReduce running on top of HDFS. And when Hive came along, it basically took MapReduce as an execution mechanism and layered SQL functionality on top of that. So Hive basically translates SQL into a sequence of MapReduce jobs and then runs those jobs one after another. So in essence, you still have basically batch execution for your SQL queries, which is why you see those latencies. A lot of those latencies are basically baked into the MapReduce environment. In contrast to that, Impala is really very much like I said, a parallel database system where you do not have batch-oriented execution. A query is now translated into basically a sequence of query operators that are then sent not to MapReduce, but to an Impala daemon that runs on every node and that is always on, so to speak. And that daemon takes it and translates it and executes these. Basically, it does joins, scans, and aggregation in response to what is being sent by a coordinator node. And so what that means is that you're cutting out the batch overhead that you're getting with MapReduce. And there are also other forms of efficiency gains that we realized in Impala. And so the difference here is that with Impala, it is possible to get interactive speed. In fact, that is one of the biggest use cases for it, to basically take business intelligence tools and connect them directly to Impala and then run queries interactively against your Hadoop cluster.
Okay, so you're completely skipping Yarn and MapReduce and just going straight to the HDFS and the backend data store itself, right?
Yes, that is correct. So Yarn is somewhat outside of that. Yarn is a resource manager, and but Impala does not at present integrate with Yarn, and in particular not at the level of an individual query. Again, this is because it would add execution latency. And likewise, Impala completely skips, or I wouldn't even say skips, Impala simply does not access MapReduce in order to talk to HDFS. HDFS is a component of the Hadoop ecosystem all in itself, and has an API and can be accessed just like MapReduce does. So there's no need to have MapReduce in the mix.
So is Impala normally ran as standalone? You said you can use it to do real-time data, but like in our environment where we're kind of multi-tenant, we have multiple people, and we use some of the scheduler features to kind of enforce fairness, it sounds like Impala lets people go outside of that. So how does Impala kind of interact with a standard MapReduce environment?
So Impala is typically installed inside standard MapReduce environment. It basically shares resources with a Hadoop cluster. The way this is typically done is through Cloudera Manager, which allows you to set up Impala side by side with MapReduce on the same nodes using Linux containers. So you basically get resource partitioning, but you're still staying on the same node. So you would basically say, I have 64, 128 gigs of memory available on a node, and you would decide a certain fraction of that should be dedicated to Impala.
Are there other forms of resource management that Impala does? So, again, I'm coming from a strong HPC bias where we, resource managers are life, right? You submit your job, when there are resources to run your job, the resource manager gives you the resources, your job runs, and then those resources are released for somebody else, assumedly somebody else's job. Do you do that kind of thing in Impala, or if someone submits a million queries all at once, do they just run, subject to normal Linux multitasking and memory constraints and things like that?
Good question. Impala has a form of resource management built in that is called admission control. So in essence, all Impala nodes are peers, and you can submit queries to any Impala node. You can submit queries as part of a resource pool. And as part of your pool configuration, you can specify how many concurrent queries are allowed to run for this particular pool, what the total amount of memory is that can be reserved by the queries in that pool, and how many queries you are allowed to queue for that pool. And so what happens is on query submission, that node then checks basically the global state of the cluster to see if it is allowed to run this query based on the concurrency limitation and the memory limit. And if that's not the case, it will queue that query.
Okay, so how does this compare to, there's a lot of scale-out databases out there now that kind of compete with the traditional database world. How does this compare to, you say, pick out some of the common ones like Cassandra or MongoDB, which I know these all cover different spaces, but kind of give us the use cases.
So the two that you just brought up there, Cassandra and MongoDB, are really more comparable to storage managers such as HBase or even HDFS. So they're really at a different level in the basically data management stack. So for instance, looking at HBase and Impala, HBase is not a replacement for Impala or Impala a replacement for HBase because they are really at different levels of the stack. Impala can run queries against HBase. So it basically functions as a storage manager and data provider to Impala, just like HDFS does. And you could do the same with Cassandra and MongoDB, for instance.
So this is fitting in more to SQL a little bit in terms of regular relational databases?
This is more, well, this certainly is SQL. It gives you SQL interface, whereas these particular storage managers also give you particular update functionality for your data, which Impala does not provide. It relies on the underlying storage manager for that purpose. But Impala also allows you to run queries against data that sits in HDFS and in HBase. So for instance, you can join, if you have, let's say one table sits in HBase, one table sits in HDFS, you can join those two.
Okay, so my brain is a little bit exploding here. All my conceptions about what I thought I understood about Impala, I'm finding out are wrong. Fantastic. So are you saying that Impala is kind of like a meta database manager then?
Well, I would say that Cassandra and Mongo are not databases. They are really storage managers. And Impala is a query engine that can talk to any of these storage managers, except it doesn't talk to Cassandra because we don't have an interface to it, but it talks to HBase. HBase is comparable to Cassandra in terms of the functionality it provides.
I see.
So in that same vein, it also talks to HDFS, and it talks to a new storage manager that is being developed at Cloudera called Kudu. Kudu is similar to HBase, an online storage manager that gives you individual row insert, update, and deletes, as well as high scan throughput.
Okay, so your main input and output is SQL queries, but the underlying of what you talk to may or may not be exactly that. And so you're kind of applying those semantics to whatever the underlying data is. Do I finally have this right?
That's correct. We basically give full SQL access to any of the data that Impala can talk to.
Okay, well then let me ask an obvious question. What does it mean to do SQL queries on unstructured data?
So I think a lot of people have different interpretations of what that means. There's also unstructured as a term you hear a lot. There's also semi-structured. In essence, these I think unstructured is a misnomer, because really when you're talking about things like JSON or other forms of, I would say, nested structures, it is not the case that there's no structure. It's really that the case that there is a more complicated structure that does not fit into the flat relational model. So unstructured really means often nested relational structure. And there are storage managers that basically give you access to nested relational structures. Mongo is a good example with a JSON interface.
So in normal SQL servers, a regular database admin is focused on things like, how do I enforce ACID, and then just like standard old CRUD, of course. You mentioned row level updates and things like that, but a lot of times to get scalability, even in regular file systems, we throw out certain forms of assumed consistency or enforced consistency. What sort of trade-offs, if any, does Impala make to get this massive scalability?
So Impala, by virtue of not being a storage manager or having a storage manager, basically leaves those questions up to the underlying storage managers that it talks to. So for instance, if you take HDFS, which is an append-only file system, you are basically left with something where it's impossible to do row-level updates. So Impala against HDFS only gives you the ability to insert data in bulk. You can run basically an insert statement, insert into, select something from, or you can append entire partitions. Or you can simply ingest data by copying your raw data into the directory that forms part of a table. So in essence, Impala does not get in the way of what the underlying storage manager does for you for transactional data management. On HBase, you can do single row transactions, for instance. So the same is true for Kudu. So Impala really defers all of that to the underlying storage manager.
Okay, so what is the use case for Impala? Like, why would I use Impala instead of a traditional MySQL, Postgres, pick your favorite SQL database?
So to address the specific examples that you mentioned, those are, of course, single node monolithic database systems. And Impala, to start with, is a scale-out architecture. So obviously you get the benefit of higher performance and higher scalability through that architecture. That is one example, or one reason why you would want to use that. Now, there are other, our commercial competitors, which basically are monolithic parallel analytic database systems. You can ask yourself, why use Impala compared to those? And that often boils down to a question of why store data in the Hadoop environment. So we see a lot of our customers wanting to standardize that data storage on Hadoop because of the scalability and also economics of putting data into Hadoop. Impala runs directly against the data sitting in Hadoop, so you do not have an individual, a layer in the middle that makes it necessary to extract data and load it into a separate system. So you basically have the immediacy of data access that is already in the Hadoop environment when you're using Impala. On top of that, we've also found that Impala runs, in a lot of cases, a lot faster than our commercial competitors. So you also get some performance advantage.
All right, now one of the big benefits of using Hadoop and MapReduce and Yarn and things like that is what's touted as the data locality kind of thing, that your compute goes and runs where on the server where the node actually resides. Does Impala tap into that as well, or does Impala have its own data map to know where things are? Because you mentioned that there's an Impala daemon on each node, and you break up the query to run on the nodes where the data is. How does that work?
So Impala is also architected to run, basically to do local query execution. And what that means is that when a query comes in, and it is planned. So you're given a SQL statement, and you're breaking that up into a sequence of plan fragments, each of which itself is a sequence of plan operators. And Impala then figures out where the data lives that is being referenced by these plan fragments, and then runs the plan fragments on the nodes where the data lives. And so let's say Impala then does a scan of HDFS data. It talks to the local HDFS data node, and there are optimizations in HDFS that basically allow you to bypass the data node protocol and talk directly to the underlying file system. It's called HDFS short circuiting. And that's something that Impala takes advantage of. So there's very much the concept and the advantages of locality baked into Impala.
So when I go to import data and I use insert, what exactly happens during that process?
When you're inserting data via the insert statement, you're typically doing that by running a select. Let's say you're selecting from one table, inserting into another, doing some data transformation in the process. It basically Impala runs those select statements on all of the data nodes that are in the cluster, and basically does the pre-processing and the transformation locally, and will then do the insertion. And the way it does the insert, it depends on whether you have a partition table or an unpartitioned table. If you have an unpartitioned table, it's simply each data node or each local Impala daemon simply takes the data stream and writes it out to disk locally. That's it. So this is basically fully parallelized, running everywhere. If you have a partition table, Impala then redistributes the data that it read locally on the partition keys, and again spreads out the total data volume across all nodes, and then writes the partitions again locally. So there's basically, and in the partition case, there would be a redistribution step in between. But in essence, data loading is fully parallel.
So, quick question about that though. Like you're referring to an example where I'm basically doing, insert into where select from, like the usual way of kind of creating a result table from a query. But for a normal type of situation, how do I actually like bulk load or even more interactively load data? Like, I guess what's the client interface for Impala look like? Like, how do I hook up how am I putting web stats into it, or how am I putting in, buoy sensor data into it? Like, what's the actual external look like for inserting data into the system? Because we keep talking about creating new tables from tables that already exist. How do I make that first table?
This depends very much on the storage manager you're using. So let's take the standard case of using HDFS. The way you would, let's say, load weblogs into the system is that you have a log extraction process that writes data directly into HDFS. And it would often write that to a location that is then mapped into a table that's accessible from Impala. So in this case, the data loading step is really happening outside of Impala. And this is a very typical scenario. And this sort of illustrates the componentization of the data management functionality in the Hadoop environment. That you're not just interacting with one component as a monolithic system, but that you have multiple components. So this is one example of what you would do in HDFS. And again, HDFS is an append-only file system, and which is why you would do bulk loads in that case.
So another benefit of doing MapReduce and Hadoop kinds of things on HDFS is with the data replication. The typical, I think the default replication is 3 times and so on. When you run an SQL query, is Impala aware of that data replication, and does it actually execute its subqueries in multiple instances, and whoever answers first actually is the one with the data? Does it take advantage of that kind of parallelization as well?
Impala is aware of the replication, and what you just gave as an example of how you could parallelize query execution. Impala does not do that because obviously that would increase the load on the system, right? If you ran everything 3 times, and simply take the one that returns first would reduce latency but increase load. So we decided not to do that, but it would be possible to do that as well.
So what are typical use cases then for Impala? Are they just basically, I mean, is the use case you're going for is any old SQL kind of application that you have today, you can just move it to, say, a scalable data store such as HDFS, run it through Impala instead of your current monolithic SQL database or even MPP, and you will see wonderful speed up and scale out types of storage. Is that kind of where this is aimed?
So I would say the sweet spot for doing analytics and business intelligence in the Hadoop ecosystem is somewhat dictated by the limitations of the underlying storage managers. So we brought up HDFS, which is sort of the standard way of doing this. And by its very nature, because you cannot do individual row updates, you will be doing bulk loads, meaning you have somewhat, you're often restricted to loading fact table data at certain intervals and querying it then through Impala interactively. A typical use case would be to do it through a business intelligence tool that you would connect to Impala via ODBC or JDBC. Taking a completely random application and retargeting it to the Hadoop ecosystem can be a bit problematic at the moment because of the possible need for row lookups or updates of individual rows. So those require more different kinds of storage managers, online storage managers, such as HBase or Kudu. And you get different trade-offs then.
Okay, so I'm familiar with some of the Hadoop native storage formats, but Kudu I've never heard of. Can you tell me more about Kudu?
Happy to. So Kudu is a storage manager, similar to HBase, similar in the sense that it has a similar API. It is architected differently than HBase, so it is not a storage format. So a storage format is basically just a convention, but Kudu basically gives you an API and is a running system. Kudu gives you individual row lookups and insert, update, and delete functionality. But it also, which HBase gives you as well, but in contrast to HBase, it also gives you very high scan throughput. And so the goal is, especially the combination of Kudu and Impala, is to basically give you the functionality that you have in a typical RDBMS, but have it be provided in a scalable manner. So you can basically do run statements that do an individual row insert as well as an update statement or a delete statement, which currently is not available against HDFS. But with Kudu, you can then also run very fast analytics against the same data.
Yeah, okay, we flubbed that one. Sorry. Sorry, little known fact, Brock and I actually pass a baton back and forth in Instant Messenger, and right when he was ending, he said, "Okay, you." So I was not ready. Okay, dumb question. I don't know if this will make the error or not. What you said it has a high scan rate. What is a scan rate?
Basically scan throughput. Reading data in bulk, basically the rate of data that you can extract in bulk. So example.
Okay, you know what? Actually, let me go ahead and ask that as an actual question. Let's go ahead and put that in because that is not what I thought you were going to say. So cool. Let's do that one. All right. All right, I think I followed everything you said in there, except at the very beginning, you said that in contrast, Kudu is designed for a very high scan rate. What is your definition of a scan rate?
Happy to answer that. So by scan rate, I mean the rate at which you can extract data in bulk. So in a file system, you would typically quote that as megabytes per second per disk. And in Kudu, you could do it in a similar manner or say rows per second. In essence, if you want to run big analytic queries, you need a high scan rate in order to get good performance.
Okay. All right. Now, we've kind of skirted the edges of use cases and whatnot, but who is deploying Impala these days? Where is it being used? Are there particular verticals, or is it being broadly used? Give me some idea of the adoption here.
Impala is actually very broadly used among the Cloudera customer base. It is not restricted to any verticals, so it's really used across all of the verticals that are Cloudera customers. I think something on the order of 50% of Cloudera customers are using Impala. And oftentimes, or not oftentimes, for the most part, it is used for analytic querying against HDFS. So often in combination with business intelligence tools. In a lot of cases, this happened because there was a desire to replace an existing system, an existing commercial monolithic system that was either, let's say, too slow or was coming up against its capacity limits, or there might have been a new application that they decided to try on Hadoop directly as opposed to some other system.
So I want to back up for one more technical question. You talked about the high scan rate, and that's what's necessary. Is there any concept of indexing or anything like that, like you'd have in a let's say traditional type of database engine? Is there anything like that to help with this?
So in the traditional database system, you have typically two forms of indexing. One is primary index, or what's called a clustered index, basically how your data is physically organized. You can organize data by some kind of key, and then it's sorted or something like that. And there's also secondary indexing, which is what most people think of as indexing, which is a separate structure, often a B tree, that then refers to the original data. In HDFS, but also in Kudu, you have primary indexing. So Kudu allows you to basically partition your data based on a hash key or a range partitioning. Kudu does not support secondary indexing at this point, but it is conceivable to layer that on top as well.
So then back to the way people are using Impala today. Very early on in the big data world, I started hearing things like, don't denormalize your data. Is there any differences? Like, if I'm coming from a traditional database background and I'm being asked to work with something like this, should there be any major changes I should think about in terms of the way my data is laid out, or the way I should actually query my data when I'm working with a system like Impala?
So I think blanket statements like don't normalize or denormalize your data are not really appropriate. It really depends on the use case and also the data size, etc. So I think this is very use case specific, and I'm not sure it can be answered, just like that. There are so for instance, it's incorrect to say you should try to avoid joins in those systems, right? Impala is perfectly capable of executing joins, and denormalizing everything as an example, or as an extreme example, denormalizing everything into one giant table also carries fairly big performance penalties in a lot of cases. So I think you really need to look at the specific use case.
Okay, so generalizations are bad and use cases are specific, but are there any types of learned wisdom that you have accumulated from doing this? Because this is taking a particular view of the world and of underlying data structures and applying it to a specific set of tools and applications and whatnot. What are some of the things that you have learned from this process to just further the state of the art, or just understanding of how people do, large data queries? What is some of the gained wisdom here?
I think what is very important is to look for the proper, I would say, partitioning of the data. So there are data sets that are, I would say, too small in order to benefit from very large clusters, obviously, right? For instance, the preferred storage format for Impala is Parquet. It's a columnar format. It gives you good compression. What that means is that if you have relatively small data sets, they will compress to even less data in Parquet. And then taking that data and trying to spread it out among, let's say, 100 nodes or more can be difficult. And then you won't really get the benefits from a scale-out architecture. So there is such a thing as too little data for a large cluster.
So, the organization of Impala, Impala is currently listed as a Hadoop incubator project. What exactly does that mean?
So we're in the process of becoming an Apache project, and every project that is going through that basically goes through an incubation phase where you are basically converting your infrastructure and your processes to be ASF compliant. So right now we're in the process of moving our code review tools and our Jira our issue repository over to ASF compliant infrastructure, for instance. At the end of this process, you're basically graduating into a top level project, at which point you are a fully grown Apache project.
So what other community members are involved in Impala?
Impala has seen contributions from Intel and from Google and from a company called Arcadia Data.
Now, when you say contributions, is Cloudera the primary contributor, or have there been large contributors? Are they active, or do you just every once in a while get code thrown over the wall from these other members, or how does it typically work?
We have Cloudera as the primary contributor, absolutely, and we're working with these other contributors on a per project basis, I would say.
All right, and what is the user uptake? So a common characteristic of these open source communities, particularly in the Apache world, is that you actually get a lot of user interaction as well, not just asking questions, but sometimes even reporting bugs and submitting patches and things like that. How do you guys anticipate adapting to that kind of model, or are you already there?
We're seeing active user discussions. We have a user mailing list, etc. So there are often questions about things from architecture down to how do I compile this, or how do I deal with this compilation error, or I'm seeing this behavior, how can I fix it, stuff like that. We haven't really seen contributions. We have seen some contributions, not a ton, I would say. Impala is a moderately large code base, so it's not something that you can just jump into very easily, but it's definitely attainable.
So, how fast is Impala? I mean, is it fast in terms of data size or queries per second? How would you classify how fast the system is?
So Impala was basically targeted, or one of the main goals of development was efficiency, and so which implies both low latency as well as high throughput. So typical BI environments are geared towards having multiple users interact with the system through a query tool, and so in that environment, throughput counts, obviously. So that was one of the main motivators for doing this. Now, I don't know how to characterize how fast exactly, but it is fast enough, or so fast that we've had users basically say they're replacing the existing, let's say, appliance-based analytic database system with Impala. In some cases, smaller node count, and they're seeing substantial speed up.
Okay, then what about the size of one of these systems? What's the largest, I guess, both in amount of data stored under management and then also the largest in terms of query load?
The amount of data, I'm not entirely sure. I think in terms of node count, we're looking at probably something like 500 or 600 nodes. Query load, I'm also not entirely sure, but we've heard about in the, up to something like 100 concurrent users.
So let me ask something that I typically ask to most developers who come on the podcast here, and it's just a pure curiosity question. What kind of version control system do you use, and why?
We use Git. Why do we use that? I think it's it's suitable for distributed development, and it's well integrated into our development processes. And then aside from Git, we also use Gerrit as a code review tool.
Okay. Have you run across an odd use? Like, what's the strangest, unexpected use, or like deployment? Like, it's running out a bunch of Raspberry Pis on the moon or something like that you've seen of Impala?
That's an interesting one. I really have to think about that. I'm not sure I've actually seen sort of totally out of the ordinary deployments. The standard hardware today is basically vanilla server hardware. In terms of use cases, I don't know. We've heard some that are doing basically web apps, basically powering web apps through Impala, which means you have basically external user interaction that go directly against your Hadoop setup.
What license do you guys distribute Impala under? I imagine it must be ASF compliant, but which one are you using?
Impala is available under an ASF license.
Oh, just that one directly. Okay. And
Yes.
is your model as Cloudera, you guys sell support for it? That's how you monetize on it?
Cloudera sells basically a subscription service that includes support. Yes.
Okay, well, thank you very much for your time. Where can people find out more about Impala and maybe get it running?
Impala can be downloaded freely. There's a website, impala.io, that has links to the downloads as well as documents, blog posts, etc. And that would be a good starting point.
Okay, Marcel, thank you very much for your time.
Thanks, Marcel.
Rock, thank you.